Okay, students, when I first introduced factoring and why we want to learn how to factor, I started with this imaginary scenario where terrorists have stolen vials containing the coronavirus from CDC offices in Cincinnati, and they're heading to Chicago, Illinois in order to attack the Vista Tower with the virus. The Anti-Terrorism Task Force has set up on the roof of the tower, and they're going to launch a containment net, which is inside a rocket, in order to stop the truck and prevent the release of the virus. Now, of course, there's lots of math involved in figuring out exactly when that truck will get to the tower. But your job is to figure out how long it will take the rocket to reach the ground so that the net can be released and capture the truck at precisely the moment the truck arrives at the tower. So using some high school physics, we came up with an equation that represents the distance of the rocket from the ground. And as I said in class, this isn't exactly the perfect formula. The exactly perfect formula is slightly beyond the scope of this course. But this will do to motivate solving quadratics. So if we're trying to figure out when this thing is a distance of 0 feet from the ground, that means we're trying to figure out when negative 16t squared plus 160t plus 1200, which represents the height of the rocket from the ground, when that's equal to 0. This is called solving a quadratic equation. The first thing you should always look for when wanting to factor a quadratic is for greatest common factors. We know that we need to factor out a negative because we should always factor out leading negatives. And if you divide 16 into each of the coefficients in this problem, you will find that it's a factor of each. So we have a GCF of negative 16. So we're going to divide that out of each term, which leaves t squared minus 10t minus 75 inside the parentheses. So we have negative 16 times that quadratic, and since negative 75 is equal to negative 15 times 5, and negative 15 plus 5 is negative 10, we can use our product sum technique to factor this quadratic into negative 16, open parenthesis, t minus 15, close parenthesis, open parenthesis, t plus 5 equals 0. Now recall when we have a product, that's equal to 0, by the zero product rule, one of the factors has to equal 0. Now, of course, negative 16 can't equal 0 because negative 16 is equal to negative 16. But t minus 15 could be 0, and t plus 5 could be 0. So I have these two linear equations, and I'm going to solve them by using properties of equality. So I'm going to add 15 to both sides of this equation, and that gives me t equal 15. And I'm going to subtract 5 from both sides of this equation, which gives me t equal to negative 5. Now remember, in this problem, t represents time measured in seconds after the launch. So t equals 15 means 15 seconds after the launch, the rocket will be 0 feet above the ground. In other words, the rocket will be on the ground. So 15 seconds is the answer you're looking for. Now the t equal negative 5, this is time, of course. So time equal negative 5 would be a time that's in the past. And we don't want time in the past. We want time when we can expect the truck, and that is in 15 seconds. So we just used factoring to solve a fairly realistic real-life problem. Thank you for watching.